Okay, in this session, in this section, I'm using an example um, to apply the present value or future value of an annuity. And either ordinary annuity or annuity due. So for the annuity problems, okay, so we have two formulas. Let me write down them. First, if we want to calculate the present value of annuity, the present value of an ordinary annuity, it equals to the rent. Basically, is a payment, the periodic payments per period at the end of each period. Okay, then the present value factor, which is determined by two variables. One is number of periods, the other is interest per period. Okay, so if we want to calculate the future value of an ordinary annuity, okay, it's rent multiply future value factor, ordinary annuity, and NI. Both formulas, it includes 5 factors. Okay, for each one it includes 4, but the total is we have present value, future value, rent, and NI. Okay, so if we calculate the present value, basically 4 factors of these 4. Okay, so if we calculate the present value, yeah, these 4 factors. Okay, so now let's read the question to see what the question asks us. And this guy invests 6,530 a year for 19 years. So it implies it keep making investment every year for 19 years, same amount. We know this is an annuity problem. And interest rate is 10% per year, right? And we are also not informed how the interest is compounded, so we just simply assume the interest is compounded annually. The question asks us if the first payment into the fund occurred today, what amount will be in the fund in 19 years? Okay, let's first draw a time axis. So if you don't really, just make it the problem to be more realistic. Okay, so 19 period, 1, 2, 3. This is 18. This is 19. So total 19 periods. And each period, the payment occurs. Okay, so here the first payment occurs today. Today means 0. So first is 6,530. The next one is 6,530. 6,530. 6,530. And last one is here. Okay, so the payment are all at the beginning of each period. So this represents payment of this period. Okay. So basically we know it is what? Annuity due. Okay, so this is an annuity due. So it asks us what amount will be in the fund in 19 years. Basically, it asks us what's the future value of an annuity due. So future value of an annuity due, it equals to rent multiplies the future value factor of annuity due determined by N and I. Right? Yeah. So we know the relation between the future value factor of annuity due and the future value factor of ordinary annuity. So we can change the formula to this form. So this will be future value factor of ordinary annuity, N and I, multiplies 1 plus I. Okay? So now we can apply the numbers. Rent is 6,530. The future value factor of ordinary annuity, you can look up table, I think it's table 3, right? So N is basically is 19, right? Interest is 10%. Okay, row number 19, column 10%. You can find that the factor is 51,15909. Don't forget, you have to accumulate one more period. Now, the future value will be $367,476. So in other words, if this guy invests 6,530 every year at the beginning of each year for 19 years, and the interest of each year is 10%, interest is compounded annually. If he does this, he can receive this amount by the end of 19th year. Okay, so this is annuity due. Next question is, if the first payment occurs at its end, so what's the amount? Now, again, let me use another axis. Let me use a different color, okay, to show their difference. And this is 0, this is 1, this is 2, this is 3 period, this is 19, and the rent is by the end of each period. Yeah, basically we just move the payment, or lag the payment for one period. It's one period. So this payment represents period 1, this is period 2, this is period 3, this is period 17, this is period 18, this is period 19. Okay, so this is ordinary annuity. We also ask for the future value. So the future value of ordinary annuity, it equals to rent multiply future value factor of ordinary annuity, NI. The rent is again same, 6,530. Future value factor is determined by N. What's N? It's 19. Interest is 10%. Okay, so this actually is this one. 6,530, 51,15909. So the result is 334,069, which is less than the one we had in the prior question. Okay, why? Okay, same. Basically, the payment is just one period lag behind, right? See, this cash flow will move here. Let me use a different color. Move to here. This move to here. This one to here, right? So why the annuity due has greater value than ordinary annuity? Even they have same amount of rent, same number of period, and the same interest rate, and the interest is compounded samely. Yeah, the reason is, annuity due, the cash is paid or received earlier. So it can be, or it can generate interest earlier based on the concept of compound interest. So it can keep accumulating interest earlier. So that's why its value will be greater.